James Webb Telescope just discovered an amazing, potentially fully habitable planet. The launch of the James Webb Telescope in 2021 marked the beginning of new discoveries that will forever change the way we view our planets. Some scientists and astronomers had described it as a technology that could finally give insights into the origin of things. So far, James Webb seems to be living up to expectations with mind-blowing discoveries. For as long as we can remember, humans have been on the search for other planets with the possibility of supporting life outside Earth. This has led to many exciting discoveries and the launch of unmanned crafts into Mars. But, however, the search hasn't come to an end yet. Just recently, the James Webb Telescope discovered something that might finally be the end to this search. Though further research is still required to fully understand the possibilities presented by this discovery. In 2013, the Wide-Angle Search for Planets, or WASP, using the transit method, which involves looking for dips in the brightness of a star when a planet passes in front of it, discovered an exoplanet that's really significant and is known today as the WASP 96b, named after the observation that discovered it. The interest that this discovery sparked led to further inquiries into the nature of this body, and I must say, there have been some really amazing discoveries about the planet. To begin with, exoplanets are planets that orbit stars outside of our solar system, and up until now, they've been really difficult to observe with the older technologies that were in place. Since 2013, some of the discoveries about the WASP 96b include its large size and short orbital period. WASP 96b is estimated to be about half the mass of Jupiter, but it orbits its star every 3.4 days. This short orbit time it has makes it one of the shortest period gas giant planets known. Secondly, WASP 96b has been found to have a rich sodium atmosphere. In 2018, astronomers using the European Southern Observatory's Very Large Telescope, or VLT, found evidence of sodium in the atmosphere of WASP 96b. This was the first time that sodium had been detected in the atmosphere of an exoplanet, and the birth of more advanced observatories was bound to reveal more about this planet. Fast forward to 2022, following the launch of the JWST in 2021, some jaw-dropping discoveries that will change everything we know about the planet were made. One such is the discovery of the presence of water vapor in its atmosphere. In 2022, the James Webb Space Telescope detected the unambiguous signature of water vapor in the atmosphere of WASP 96b. This was the first time that water vapor had been detected in the atmosphere of an exoplanet, which owes its discovery to the advanced technology built into the JWST. Now, you might be wondering why the discovery of water vapor should be such a big deal. Well, the discovery of water vapor in the atmosphere of WASP 96b is pretty much a significant finding, as it suggests that the planet may, after all, have the potential to support life. However, the findings haven't been conclusive on the matter, and more research is needed to determine whether or not WASP 96b is actually habitable. And if this turns out positive, it will be one of the greatest discoveries ever made. These discoveries have led both scientists and astronomers to learn a great deal about the physical properties of WASP 96b, such as its temperature, density, and composition, which have been highlighted more by the JWST. The pieces of information gathered so far have helped astronomers to better understand the formation and evolution of gas giant planets and even more. Now, let me take you through the details of the recent findings by the JWST. The James Webb Space Telescope, as I already made reference to, discovered the unambiguous signature of water, along with evidence of clouds and haze in the atmosphere of WASP 96b, which is a hot, puffy gas giant planet that orbits a distant star. The clarity provided by this observation is the most detailed of its kind to date, demonstrating Webb's unprecedented ability to analyze atmospheres hundreds of light years away. And we are yet to see the limit this technology can go. WASP 96b is located about 1,150 light years from Earth, making it a whole lot more difficult to observe. The exoplanet orbits its star every 3.4 days. The planet is about half the mass of Jupiter and has a surface temperature of about 1,000 degrees Fahrenheit, which might be the real deal breaker in its habitability. The infrared camera that the JWST is equipped with seems to be the most significant factor in play in the amazing discoveries made by the observatory. The JWST's near-infrared imager and slitless spectrograph captured some really detailed data while peering at WASP 96b for a short period of 6 hours. The discovery includes a spectrum of the planet's atmosphere, which showed clear absorption features from water vapor, as well as hints of other molecules, such as carbon monoxide and methane. The presence of water in WASP 96b's atmosphere is significant because it goes a long way in establishing links between our own planet and others in the universe. For one, it suggests that the planet may have just formed in a similar fashion that our own solar system did. And the most striking likelihood that this presents is that it also means that there might be potential for life on WASP 96b. So far, water seems to be a basic component that is required for life to thrive anywhere, and its presence on this planet is pretty much a hint of that. This brings to mind the obsession that humans have had over the years with the search for evidence of any other life forms somewhere in the universe. As previously stated, it's important to note that these recent discoveries aren't stating categorically that WASP 96b is a habitable planet. At least not yet. The surface temperature of about 1,000 degrees Fahrenheit makes the planet too hot for life to thrive. This is a result of the planet being too close to its star, which makes it too hot for liquid water to exist on its surface. However, the discovery of water in its atmosphere is a major step forward in the search for life beyond Earth. The JWST is expected to make more discoveries about exoplanets in the coming years, and there's no telling what we might find next with more observation. With its powerful infrared vision, the telescope is able to peer through dust and gas to see the atmosphere of planets, which has been a feat too difficult to be realized with other older telescopes. This vast data provided by JWST will help scientists to better understand the composition of exoplanet atmospheres and to search for signs of life. Understanding the workings of the world around us is a step forward to harnessing the vast resources that are available to us. And this has been the major driving force behind any innovation that has happened over the years with humans. Such curiosity led to the advancements of telescopes like the JWST, which has some pretty major gaps from the older models. The James Webb Space Telescope has presented a number of advantages over the equipment that was used during the WASP observation. To begin with, the JWST comes with a way larger primary mirror. For scale, the JWST's primary mirror is 6.5 meters in diameter, while that of the telescopes used in the WASP observation has a primary mirror that's only 0.5 meters in diameter. This gives JWST an edge in performance significantly. The presence of larger mirrors in JWST means that it can collect more light and see fainter objects than those used in the WASP observatories. This has led to the revelation of some really amazing bodies that have so far eluded humans. The JWST is also known for its famous infrared sensitivity, which reveals certain occurrences that can't be seen with the eyes. JWST is designed to observe infrared light, which is a significant advancement to the telescopes used in the WASP observatories, which are primarily sensitive to visible light. This means it can see only things that will be ordinarily visible to human eyes. This addition means that JWST can see through dust and gas clouds that obscure visible light, allowing it to see objects that would otherwise be invisible. The sheer location of the JWST, which is in orbit around the Sun, gives it an edge over those used in the WASP observation, which is located in Earth's orbit. This means that JWST is not affected by Earth's atmosphere, which can distort and blur images. As a result of these advantages, JWST is able to see objects that are much fainter and more distant than the WASP telescope. With this, we are sure to have more amazing discoveries that will shake most of the foundational knowledge we already have about the universe.